So this video is on the Chapter 12 D-Day number 2, which is Wednesday's D-Day. So first thing we want to do is number 1, if this is for all, so we have to pay attention to that. We're going to get the sine squared x by itself, everything else to the other side. So we're going to have 4 sine squared x equals 1. I'm going to divide by 4. So I get sine squared x equals 1/4. I take the square root. So I get sine x is equal to, and when I take the square root, I get a positive and a negative. The square root of the numerator and the square root of denominator. So I get the square root of 1 is 1, and the square root of 4 is 2. So I'm looking at a positive and negative 1/2. Now sine is your y. So I'm going to want long, short, because I want my y to be short. So I'm going to go long, short, which puts me here at pi 6, which also means I'm here at 5 pi 6. I'm also here at 7 pi 6, and here at 11 pi 6. Now, this is for all, so I'm going to do the plus or minus 2 pi n, but I notice that from here to here, going all the way around to here, that is 6 pi 6 or pi. So I can take pi 6 plus or minus pi n, and that's going to get me these ones. And then if I take my 5 pi 6 and add pi, I end up with this one. So another answer is going to be 5 pi 6 plus or minus pi n. And so those are going to be our answers. And again, when we're looking at this, let me just get rid of this for a second. You want to kind of look to see if you can go from one to the other. So from here to here would be 4 pi 6, but from here to here is only 2 pi 6. So I can't just take my pi 6 and add and subtract to get my 5 pi 6 and then my 7 pi 6. But as I showed, I can add pi, which is 6 pi 6, to my pi 6, and you see that's half of a semicircle, so that's going to be pi away. And I can do the same. Whoops, I'm just going to change the color. Same from here to here. If I add pi, which is half of a semicircle, you see I end up in the same spot. Okay, on number 2. Okay, find all solutions. So again, this is a for all. So I am going to get cosine squared x equal 1. So take the square root, and I take the square root of 1. That's going to be a positive and negative 1. Cosine is your x. It's going to be here at 0 and pi, and then back to 2 pi and so forth. So that's going to be pi away from each other. Okay, that's pi away from each other. So my answer is going to be 0 plus or minus pi n, or plus or minus pi n. On number 3, this one I'm going to get equal to 0 first, because I have a cosine squared x and a cosine x. So I need to get the -1 here equals 0, and then I'm going to factor. So if you need to, you can factor doing a box to diamond, okay? But I think we could probably do this just straight. But if you need to do the box to diamond, do a box to diamond. So I'm going to have a 2 cosine x and a cosine x. That's how I'm getting the front, this 2 cosine squared x, okay? And then in the back, I need to get a -1. So that's going to be a positive 1 and a negative 1. Since I need a negative cosine x, I think I'm going to have my -1 here, because that's going to give me a -2. And then my positive here. Okay, so now basically, this is going to be 2 cosine x equals -1. So cosine x equals -1/2. My other one is going to be cosine x equals 1, and this is another for all. So let me start with the cosine x equals 1. That is going to be at 0 plus or minus 2 pi n. So 0 plus or minus 2 pi n. For the cosine -1/2, that's going to be short comma long, short, long, but over here in this quadrant, okay? So this is going to be 2 pi thirds, and this is going to be 4 pi thirds. And then you see the distance from here to here is not the same as the distance from here to here. So I can't take 2 pi thirds and add something to get 4 pi thirds and get back to 2 pi thirds. So I am going to have 2 pi thirds plus or minus 2 pi n. And I'm going to have 4 pi thirds plus or minus 2 pi n. So let me do this. So my whole entire answer is this. On number 4, we are trying to verify. So I need this side to stay, and I'm going to change this side. So I'm thinking I'm going to rewrite my cotangent in terms of sines and cosines. So cotangent of theta is going to be cosine theta over sine theta. And then this cosecant theta, that's going to be 1 over sine theta. And so now if I'm trying to clean that up, it's going to be cosine theta sine theta. When I'm dividing by 1 over sine theta, I can times by the reciprocal. And then what happens here is this and this is going to cancel. So now on the left side, I end up with cosine theta. And on the right side, I was trying to get cosine theta. So there you go. Number 5. Okay, so again, I'm trying to get that. So since I need to get a 1 minus sine x on bottom, what I'm going to do is I'm going to start with 1 plus sine x over 1. I am going to multiply top and bottom of this by 1 minus sine x, 1 minus sine x, because that's just a fancy 1. But that will allow me to get a 1 minus sine x in my denominator. So let's see. So I'm going to have a 1 plus sine x times 1 minus sine x over 1 minus sine x. When I'm looking at this, this is a difference of 2 squares. So that's going to become 1 minus sine squared x. And that's over 1 minus sine x. And then when I'm looking at this, this comes from our Pythagorean triple, our Pythagorean identity. So remember our Pythagorean identity, I'm going to write in orange up here, sine squared theta plus cosine squared theta equals 1. So if I was to keep my cosine squared theta here and subtract my sine squared theta, you see that cosine squared theta is the same as 1 minus sine squared theta. So I can rewrite the top as a cosine squared x. And on bottom, I have 1 minus sine x. And what I was trying to get right here is cosine squared x over 1 minus sine x. So my left ended up becoming my right. My second number 5, there's 2 number 5s here. So we're trying to get this. So the secant x minus 1 times the secant x plus 1. This right here is a difference of 2 squares. That's going to be secant squared x minus 1 when I do that math. And then we're trying to get a tangent squared x. So I'm just going to remind us that if I have sine squared x plus cosine squared x equals 1, that is a trig identity. If I can get a tangent, and I can get a tangent by dividing by cosine squared x, cosine squared x, cosine squared x to get tangent squared x plus 1 equals secant squared x. Now, if I was to rewrite this, tangent squared x is equal to secant squared x minus 1. So this right here is going to help me with this. So that, because of that Pythagorean identity, is equal to tangent squared x equals tangent squared x. There you go. Number 6. So for this one, I'm in quadrant 3. I have angle A. Sine is a negative 4/5, so sine is opposite over hypotenuse. Now the negative has to go here because my y is negative here. And then if I solve this, this would be a 3, 4, 5. So I have a couple of different formulas for cosine of 2a. So I have cosine of 2a is equal to, and let me get that paper up. So this is that sheet with all of the formulas. So what I'm looking at are these double angles. And in particular, I'm looking at these cosine of 2a. So I could use any of these. Since I have my sine, I could just use this one, which is 1 minus 2 sine squared a. So 1 minus 2 sine squared a. So that would be cosine of 2a is equal to 1 minus 2. And my sine is a negative 4/5, and I'm going to square that. So I'm going to get 1 minus 2 times 16 over 25, which is 1 minus 32 over 25. So I am going to end up getting, when I do that math, this is really a 25/25 minus 32/25. So my cosine of 2a, okay, my cosine of 2a is going to equal negative 7 over 25. That's going to be my answer. And again, I chose to use this one. I could have instead done this one and put in a 3/5, a negative 3/5 for this and work it out, or put in my negative 3/5 here and my negative 4/5 here and square them. Any of those are going to give me the same answer. Okay, I chose the one with the sine squared a because I have my sine a already. So I really didn't even have to find this. And actually this is a negative 3 because of the quadrant I'm in. Okay, number 6. Oops, no. Number 7. Okay, so cosine inverse is going to go from 0 to pi. That's where I'm focused for cosine inverse. And I want to find where my cosine is a negative root 2 halves, which is going to be right here, which is a pi fourth, and this is 3 pi fourths. And that's your answer, 3 pi fourths, because you want the angle that gives you a cosine of negative root 2 halves. On 8, first thing I need to do is find tan of pi. So this is pi, which is negative 1 comma 0, and tangent is y over x. So I'm going to get 0 over negative 1, which is 0. So then I want sine inverse of 0. So sine inverse goes from here to here, which is negative pi halves to pi halves. And my sine being 0, we want my y to be 0 is right here, which is 1 comma 0, but that radian is 0. So my answer is 0 in terms of 0 radians. Okay, so on this one, when I have sine times cosine of an angle minus cosine times sine of an angle, again, we want to be looking at this, and I'm going to be looking at the sum and differences, and I'm going to be dealing with this one here, okay? Because I'm having a sine times of one angle times the cosine of the other minus the cosine of the first times the sine of the second. So I can make this into a single sine of u minus v, okay? So in this case, this is going to be sine of pi 6 minus pi fourths. And if I get a common denominator, which is going to be 12, it's going to be 2 pi 12ths minus 3 pi 12ths. So that's going to be sine of negative pi 12ths. And they didn't ask us to find the value. They just wanted us to write it as a single trig function, okay, instead of having multiple trigs, sine and cosine. And we want a single angle instead of multiple angles. And so that's your answer. Okay, 9, looking at this, I am going to factor a sine x from both of these. So I'm going to get a sine x times 2 cosine x minus 1 equals 0. So this, I'm going to have sine x equals 0, and that is going to occur here at 0 and here at pi. And then if I'm trying to solve, oops, didn't mean to draw triangles. If I'm trying to solve this, this is going to be 2 cosine x equals 1. So cosine x equals 1/2. And so my cosine is a 1/2 at short long, which is going to put me here, which is pi thirds. And also down here, which is 5 pi thirds. Okay, and then if this is for all, it doesn't say that it isn't, so let's just be safe. So it's going to be 0 plus or minus pi n. That's going to give me this and this back and forth forever and ever. And x is equal to pi thirds plus or minus 2 pi n. And then 5 pi thirds plus or minus 2 pi n. And again, in terms of making sure I can't simplify my 2 orange ones, the distance from here to here is not the same as from here to here. So I can't write them in terms of each other. And that's the end of this video.